Hello, nice to see you again. Welcome to our second lecture on cloud basics. Let's get started, shall we? In this lecture, I will explain cloud technology in more depth and explain the development direction and the future of cloud technology. Through this lecture, you will get an overview of the technologies that implement IaaS, PaaS, and SaaS, and you will understand the future and the development direction of cloud technology. In this lecture, I will explain the definition, characteristics, and the technical elements of IaaS, PaaS, and SaaS, and explain the core cloud technology development direction, cloud native. IaaS is a model that provides computing resources such as a server, storage, and the network as a service through a network. Virtualization is one of the core concepts of the cloud. It refers to a technology that can logically divide one computing resource into several and use it more effectively. Virtualization allows one physical machine to create multiple logical machines that operate independently. In this figure, if you use one machine as a whole, you can use only one server, and you can use a software just operating on the server operating system. But if you use virtualization technology, virtualization allows you to use various virtual machines. And also you can use multiple virtual machines at the same time. Now, I will briefly explain the types of virtualization. The hypervisor is the previous virtualization method, and it is a structure in which a hypervisor is installed on a host operating system, and various guest operating systems are installed and used. The guest operating system runs on each virtual machine, and the user can select the virtual machine where the application can run. The container is a new technology based on Docker. The Docker engine virtualizes the operating system and divides it into separate spaces, creating the same effects as if multiple logically independent operating systems are running. Each application runs in a container, which there is a logically independent execution space. As shown in the figure, containers are very simple and light compared to the hypervisor method, and they run faster and occupy less memory, so they are very popular among cloud providers now. PaaS, Platform as a Service, is a model that provides a company's application execution environment and the application development environment as a service. In PaaS, an application execution environment or database is prepared in advance, so that an application can be developed in a short period of time to provide a service. PaaS has several advantages. PaaS provides the entire development environment, so developers do not need to build a development environment. Also, if you use PaaS, the life cycle of software from development to deployment could be minimized, making it easier to apply DevOps, which means development and operations. DevOps collectively expresses the organization, culture, and system of a company for developing and operating cloud software. Developers can focus on developing application using PaaS. When developing a software by using PaaS, developers can use the necessary development tools immediately in the form of a service through PaaS. developers can find suitable tools in the PaaS marketplace and use them for development, which can dramatically reduce development time and effort. SaaS is the provision of software as a service. In other words, SaaS providers provide the software as well as the hardware and platform to run the software right away, which makes the software available to users immediately. As long as SaaS users are connected to a network, they can use it right away without installing any software. In order for users to use SaaS, they must sign up for a SaaS service subscription and get an account. In order to use SaaS, users must be connected to a network. Users pay the SaaS usage fee in a flat rate or on a pay-as-you-go basis. I would like to explain the technical characteristics of SaaS. When a user gets a SaaS account, a tenant is assigned to the user. A tenant is a logically independent computing space for users. Users can use a SaaS within their tenant. In the tenant space, users' data is protected. The availability and the scalability of software usage can be guaranteed, and the user pays for the amount of software used. This figure shows us how compare smartphone apps and cloud SaaS. A smartphone app is a structure in which an app is downloaded from an app store and used. Therefore, the user uses the smartphone app in an independent space. On the other hand, in SaaS, users are allocated a space called a tenant in the cloud and use the application. Apps in the cloud are shared by users but are logically independent. This figure shows the structure of utilizing SaaS in more detail. When a SaaS developer develops an application and put it on the marketplace, users subscribe to a SaaS, get an account from the cloud, and use the SaaS. At this time, SaaS can be shared among users, but each user uses the app independently within the tenant. Application users pay monthly app usage fees to SaaS developers through the platform. The cloud has passed through the first generation focusing on IaaS and the second generation utilizing IaaS, PaaS, SaaS. Currently, we are living in the third generation cloud era where almost everything we think of is serviced. In the third generation cloud, advanced IT such as augmented reality or virtual reality, IoT, machine learning, robotics, and blockchain, and even artificial satellites are provided as a service type. Major global cloud companies are applying the latest IT technologies, especially artificial intelligence, big data, IoT, and blockchain technologies to the cloud. They are providing cloud-based IT technology. In the future, in the era of technology convergence, this trend of the cloud is expected to increase, and completely new forms of new IT technologies will be derived through the convergence technology. Currently, cloud technology has four major trends. First, all new IT technologies are converging based on the cloud. Second, there is a rapidly growing demand for cloud-to-cloud connectivity, that is multi-cloud or hybrid cloud. Third, as the size of data, such as autonomous driving and IoT increases, there is a growing tendency to place an edge cloud near where data is generated. Fourth, there is a growing tendency to develop software natively suited to the cloud. Cloud-native applications means software natively developed for the cloud. Since SaaS is basically in the form of a service, the most basic concept of cloud-native is to make the elements that make up the SaaS in the form of a service as well. In other words, the basic purpose of cloud-native apps is to maximize performance and development benefits by making the components of the app into independent small services and mashing them up to make a SaaS. Four elements are essential to construct a cloud-native application. First, microservices. These are the components constituting a SaaS. They can be operated and managed independently. Second is the container in which the microservice runs. Containers are the best way for microservices execution. Third, continuous delivery. This makes it very easy to deploy software to the cloud by automating the whole process when upgrading or developing SaaS. Fourth, DevOps. This unites development and operations into one organization, allowing software to evolve as they continue to be upgraded and managed. Traditional software was developed in a monolithic way, so if some part of the software had a problem, the entire software had to be stopped until the problem was solved. However, with the microservice architecture, it is no longer necessary to stop the entire software. Because of this, microservices are attracting attention as a state-of-the-art architecture that dramatically increases the agility of software. In a microservices architecture, each service utilizes an independent database. In other words, each service operates completely independently. When sending and receiving data between services, a very lightweight interface called REST is used. A microservice architecture is best suited to the realistic needs of utilizing computing resources over a network. In the existing software, when the number of users increases, then process increase linearly. But in microservice architecture, only the number of microservices for using within the process increases. In other words, in monolithic way, it is necessary to increase the number of processes that execute the entire application unit. However, if you use microservice architecture, you can scale up much more precisely in units of microservices within the application. The open cloud platform, PaaS, was developed for the purpose of reading the domestic PaaS standard, developing an open source-based PaaS ecosystem, developing the domestic software industry, and developing the public cloud environment in Korea. It is being used in Korea's e-government and the private cloud industries, and it is dramatically improving the competitiveness of Korea's cloud platform. Since Pasta is an open source base, anyone can use it for free, and it is open to the public on GitHub. Pasta was first made in 2015 after information strategy planning in 2015 and has been continuously upgraded since then. Version 6 Anelli was released in 2021 and is the current version. Pasta is a combination of 71 software based on an open source, including Cloud Foundry, and it is also released as an open source on GitHub. PaaS can be divided into one core functions that support the execution of SaaS and the development and management tools for developers, users, and operators. Development of open source PaaS verification and stabilization for core functions has been completed, and the development of various IaaS support, standard frameworks, and domestic software installations have been completed. A user portal, a management tool that supports the operator's usage measurements, monitoring, and operation control has been developed. Pasta consists of a platform for application development and execution and a platform for container execution. The application platform is based on Cloud Foundry, and the container platform is based on Kubernetes open source. Pasta enables rapid development and testing of application software by automating standardized hardware and software development and the execution environments within minutes. In other words, Pasta automates the installation and the configuration of standardized software such as framework, middleware, and operating system required for application development, dramatically reducing the time it takes to develop and test software. In addition, there is a growing tendency to share data and systems with each other through cloud platforms that are the basis for using artificial intelligence, big data, IoT, and blockchains in each industry or company. This demand can be solved through one open standard cloud platform, and PaaS is the best choice to support it. Through this lecture, you will be able to understand more about the characteristics and the development direction of the technologies that make up the cloud, and the characteristics of the cloud platform developed and distributed by the Korean government for free. I consulted a number of references to create the lecture material. Thank you for your attention. If you have any questions, please feel free to contact me by email yklee2002@gmail.com, and I will answer you directly. Thank you very much again. See you in the next lecture.